Yeah? Okay, so okay, FabAcademy 2016, week 6, electronic design. So this week we're going to make the famous Hello World board, and we're going to learn how to use Eagle. Of course, you're free to use any other of the design programs that you recommended, but Eagle is probably the easiest because there's lots of documentation and you can just follow the usual workflow. If you're interested in using anything else, then KiCad is very interesting, but you might have to make some components because they're not in the library. But this would be great. I would really like to port the library from Eagle to KiCad. If somebody wants to help me, you're very welcome. So I would start by showing you some links. The first one is this one. I will send it. Oops, this was not successful. So this is the tutorial we used in the last years. Actually, it's also the one that I used for learning. I think Jeremy Bloom was one of, he made a driver board for stepper motors that is quite known. And it's not the best tutorial ever, but it's good enough for learning everything we need for this week. He does something that we don't have to do, which is a fill layer. So normally in high-frequency designs, you make one ground layer that goes, like everything that is not a wire that connects to something is a ground layer, and they connect all of this together. You don't need to do this. So somewhere further back, high frequency is like radio. So if you want to communicate by Wi-Fi or Bluetooth, then this is what I would call a high frequency stuff. So our stuff is very simple, so we don't have to care about this. But you see that here in this design, everything that's red is connected to ground. And let's see at which point he does this. So he puts all the components, and then in a few steps later, yeah, here, maybe have a look at this. All right. So now, do you see this one? Yeah. Did you see this button, the green one on the left side? This is for the so-called ground core, and just skip this step. And it's two videos, one for the schematic design and one for the printed, for the PCB layout. And the third one we don't really need because we're doing it in a different way. I will explain you step by step on how to get from your Eagle design to a finished board. But you should study the basics a little bit. If you want, I can do a step-by-step class, but the whole thing is a lot about you trying to figure out of how to make the traces, which is a process that can be a little bit, how do you say, I think Gabriel, he summarized it very well. So you start by making the schematic design, and you heard that you have to put an LED and a switch. And in order to not burn the LED, we have to put a little resistor. There are tons of tools for calculating the right resistor that you need. So if you look for resistor and LED calculator, you'll find there's many of them. You could use this one. And what you need to know is the source voltage, which is 5 volts in our case, and the diode forward voltage, and the diode forward current. And you can look this up in the datasheet. So if you go to the Fab inventory, which is something that you all should know, the easiest way to find it is just to Google for Fab inventory. Actually, I'll do it. I already have the link, but many times I find myself needing to find it. So it's Fab inventory, and one of the first hits in Google sent you to the FabLab FAQ. And if you Google in this, if you search for hardware on this page, you get to this spot where it says the current hardware specification, and you click on this link, and you will get the whole list of everything you need for a FabLab. This is also what you would need if you start a FabLab. This is all the machines and all the tools you need. And if I search for LED in this list, I have to click a few times. So this is all the LEDs we're using. So let's say I want this one. So I copy the number from DigiKey. I open a new window. I paste this, and it puts me right away on the side of DigiKey. Or not. So this is the LEDs we're using. And if you go on the data sheet, and you should get used to reading data sheets. It looks, they're quite complicated. It's not language for non-electronic people, but you need to at least understand enough of a data sheet to figure out those 3 things that you need to know. So if you scroll down a little bit, you get the dimensions, and here you get the DC forward current, which is 40 milliamperes, and this is what we need to know. Okay, so I could show you how to do it, but I think it's better if you figure it out yourself. So you go to any web page that helps you. You can actually, it's just the simple rule with the Ohm's law. R is the voltage divided by the current, and you know what the current is, which is the 40 milliamperes. You know what the voltage is, 5 volts, and yeah. But I just it's also a good starting point to find your ways of learning where to find things. The book that Neil recommends is very complete. It's like this thick, and it has anything on electronics in there that you will ever want to know. And you don't need to read the whole book, but it's a good idea to know where to find the book and know where to find this information. It's in English.
No, but I mean is how he uses things and how hard. Like all the things that he was talking, he was
yeah.
He's talking like
yeah, don't worry. It will soon make more sense. Oh, okay. Yeah, and don't hesitate to ask me if you can't find it. Just ask me. Oh, the name of the book should be, if you go, where is it? FabAcademy. The Art of Electronics, yeah. I think I have it somewhere, so if you want, I can send you a PDF. It's $90.
hoping that the tolerance.
No, I don't have it right here, but I will find it. Okay? No.
No, it's not like German. I mean, Germany, we don't catch a door, seriously. Yeah, you don't need a VPN.
Okay, as always, have a look at the pages from last year. So this is Gabriel's page, so you see how we made the symbolic design. So here's the LED, and it goes through the resistor, through the LED. And you can see that he put 2 LEDs, and you can see where he put them. So you're free to put them anywhere you want them, but maybe it's a good idea to look at what people did before. And you're not supposed to publish your final design this time, because if not, the next years won't have to do any work. They should try to figure it out themselves. So yeah, so you won't find any designs on this ready-made. You have to do it yourself, which is not that hard, and it's a very nice exercise. Here you can see, like, so once you have all your symbolic design made, you switch to the PCB design, and you put all your components. And since you already made all the connections in the symbolic design, the PCB design will help you by showing you those yellow lines that tell you which one you have to connect to which. But many times you end up with something like this, where you have to connect from here to there, but you can't really get through because this cable also has to be there. And yeah, so sometimes you reach a dead end and you just have to start like moving your components or rotating them or giving them a different order. So this was his first attempt. Second attempt already looks a bit better, but he's still missing to connect this one to over here. And as you can tell, it's not really easy to get from here to there without crossing another cable. And I think at this point he felt more or less like this. But next attempt looks perfect. So he also gave it a little battery so it can run independently from the FTDI cable. So it's a little board that blinks 2 LEDs. And this is the file that you then generate in order to mill it. And then you solder your components. And yeah, something was wrong. Also read about the mistakes. And yeah, so this is the final result. And then, but this is still with the programmer connected. And at some point he made a little battery holder. And since you need to get to 5 volts, you need more than one little battery. So you have to put 3 in parallel so that you can get to 5 volts. And yeah, this is what he did. And I think a quite nice result. Yeah, another example is from Alexander. So what you have first is something like this, and you want to get to something like this. And Alexander was always a bit more creative, so he didn't put his components all like 90 degrees, but he put them like 45 degrees. You also don't have to make everything right angle. You can make them spiral around your PCB if you want, but it makes it more complicated. And if you go really crazy, this is what he did on the input devices. You make a PCB that looks like this, which is complete nonsense, but it works. So if you look a bit further down, he actually milled it and stuffed it and programmed it. And as you can see, it works. So here's a little joystick. This is going to be in 2 or 3 weeks when we are doing the input devices. Okay, and yeah, I think we can make it short today. The only other thing I want to mention is the self-evaluation. And please fill out the evaluation form. If not, we can't evaluate you. If you don't evaluate you, you don't pass FabAcademy. Easy. But it's, it's not a big deal. I would really like to print a poster in big so you can evaluate yourself at the wall and everybody else also sees it every day. But the printer is like one color is missing, and even if I try to print in black and white, it refuses to print. So as soon as I have some ink, I will make it big. And also, like today, somebody was mentioning that nobody makes use of the class alias. So if they're talking about the class alias, this is the address that they're talking about. So whenever you have a question that is not answered by me or by Santi or by any of your colleagues, then you could write to academy@pcn.org. This email goes to all of us, plus everybody in Valdaura. And if you have a question that is not resolved in here or in the Academy group, then you can write an email to class 16. So this reaches an audience of about 300 people, and I'm sure somebody can help you there.
That's good. Something I couldn't answer. How many feathers are
in complete, I think we're 284, according to Luciana, and in about 50 Fab Labs.
Okay.
I will ask Luciana. Yeah. Well, actually, you could just go to the FabAcademy 2016 page and take all of those labs. So there's 82 lines in this, but there's a few lines that just say labs. And since those are all labs, I would say there's 75 labs. And if you want to yeah, no, there's lines in between. Yeah. Yeah.
I have a question about some words you know
Yeah.
which is, so input output, is it the same as high and low?
No, inputs are anything you can measure. So it's also anything you can, it's your 5 senses, more or less. But actually we have more than 5 senses, and there's more than 5 things you can measure. So I would include light intensity, temperature, pressure, acceleration, inclination. A button is also an input device. A touch screen is an input device. Anything that is something you can measure is an input device. And output devices are everything that you can actuate with electronics. So turning on and off a motor is an output. Turning on and off an LED is an output. And turning on the heating, a resistor for heating or cooling a room would be an output. So yeah, basically anything that runs on electronics that makes something with electricity is an output device.
But he talked about the high side and the low side of the circuit. You did say that, right?
Yeah.
The high side and the low side of the circuit. Well, maybe he's talking about like high and low. We usually use high for denoting 5 volts, which is a logic high of 5 volts. In our like there's different logic levels. Most of our circuits are running on 5 volts. So logic high would be 5 volts, but there's also some where a logic high is 3.3 volts. So this is representing a 1, and ground or 0 volts is representing the logic low.
Did I misunderstand, but does VCC mean the same as ground?
No, VCC is exactly the opposite of ground. It's the 5 volts. Or actually, they call it VCC instead of 5 volts because it might depend on whether you're using 3.3 or 5 volt logic. But if you look for, let's see, to be honest, I have no idea what VCC means. It's probably voltage, blah, blah. Let's see what Google says. The IC power supply pin. Power supply pins. This is just a convention, positive power supply voltage. I don't know why it's CC. No idea.
And my last question is, you said the current in a circuit should sum at 0. That I don't know if you use the right technology. The voltages should sum in the circuit.
Yeah, there's a law, how's it called? Kirchhoff's law. And I think it more or less says that like if you look at the voltage drop over each component and sum all of them up, you should get to your 5 volts. Or if you take 5 volts and subtract all the voltage drops, you get to 0. Yeah? Connected to collector. Okay.
And EVE is connected to
The drain. Yeah. Or VEE. Yeah. Okay. Any more questions?
And high and low.
Sorry?
And high and low.
High and low is like depending on which logic level you're working at, either 5 volts or 3.3. There's also, it's in our case, it's always 5 volts. So high means you measure there between this one and ground, you get 5 volts, and low, you get 0.
I have another question. So when we're talking about making the circuit transparent, I couldn't put it by
So the way, well, Neil has this way of programming the circuits, and so you can make them parametric. So you can say, or in our case, we take a resistor and we drop it somewhere on our drawing surface, and you move it around by dragging it with your mouse. And let's say you're moving your microprocessor a bit to the left. Your resistor will stay at the same place, and it will crash into your resistor when you move it. If you do it parametric, you don't put the resistor just somewhere by hand, but you tell it it's let's say it's x and y coordinates. But you could also tell it that your x coordinate is the same one than the one of the microprocessor minus a certain distance. So in this case, if you move your integrated circuit, the resistor will move with it. So if you look at the cut files from Neil, he has this type of logic where he places components, let's say 20% of the height of the board, or 10 millimeters to the right of another component. So once you resize your board, it will parametrically update, and it just doesn't produce the same chaos. It's a bit like it's a bit like Rhino in SolidWorks. If you do it in Rhino, you can just drag and move by hand. But if you make it in SolidWorks, you can define some intelligence in your design, and when you move things around, other things might follow them or avoid them, or depending on what your design intended. Was this answering your question? Okay, so yeah, this assignment is not easy. Like a week for learning PCB design is not very much. but it's very doable. Last year, everybody did it quite fast. I was so happy when I made my first PCB. Especially since we had a long history of getting there, because we didn't have the milling machines, we didn't have the mills, we didn't have the PCBs, we didn't have the components. So it took us at least 3 weeks for getting there. And once we were finished, like both of us, like me and my colleague, each one made their own little board, and we took a photo with both of us with a red blinking LED, super happy. And my friend went home and he showed his mother, "Look, Mom, I made a PCB, and if I push the button, it blinks." She was like, "Ah, great." You know, my garage door opener, it also has a button with an LED, but it actually opens the garage door. So it's not very easy to how do you say, to pass on this this alegria, how do you say, this joy. So yeah, don't be surprised if you're the only one that is happy with this. But at least we have lots of peers, so you can share the success. So just a quick update on SolidWorks. I think we're starting to get a few installations. Can we do hands up for who has SolidWorks installed? Okay, who wants to learn SolidWorks and doesn't have it yet? Okay, so let's start like top one. Valdauda, any questions? Oh, John, we can't hear you.
Yeah, fairly no questions. But again, if you want me to talk about parametric design in SolidWorks, I can.
Ah, great. Yeah. You didn't see the hands up right now, but we're still missing about 4 people to install SolidWorks. Maybe 8 already have it. So yeah, we're getting closer. Okay. Yeah, I will send an email with the links to the tutorials. And if there are no further questions, then I would say that's it for today. Okay. See you soon. Maybe everybody can see us. Or not. Thank you for the... Bye-bye. Bye.